Hi dear students, welcome to my science class. Today let's start with a new lesson, that is carbon and its compounds. Dear students, in the last chapter we came to know many compounds are important to us. So in this chapter we will study about some more interesting compounds and their properties. Also, we shall be learning about carbon, an element which is of immense significance to us in both its elemental form and in the combined form. Let's begin. Yes. Now let us do a small activity. The activity is very simple. Okay, you have to make a list of 10 things that you have used or consumed since the morning. Okay, now pause the video and take a rough sheet and start making the list of any 10 things. Okay, yes, start doing it. Okay, now you just sort the things in these three columns. Okay, so if the things are made up of metal, then put it in the first column. Okay, if the things are made of metal, suppose the things which are made up of glass or clay, then put them in a second column. So other than these metals and glass, then put it in a last column. Okay, again pause the video and do it. Okay, now here I have made the list of some things. It may include your things also. Okay, in the first column, so I used fan, refrigerator, spoon, TV, pen, telephone, key, coins, tiffin box and bus. And these are some of the parts are made up of metals. Okay, in the second column you see cup, tumbler, TV, bulb, saucer, watch, picture frame, statue and bottle. So these are made up of a glass. Similarly, the others, that is other things which I used today is clothes, toothbrush, toothpaste, purse, pencil, bread, milk, books, chair. Okay. Now look at the items that come in the last column of this table. So what are these compounds are made up of? Cloths, toothbrush, toothpaste, purse, pencil, and this foodstuff, books, chair. What are these compounds? What are these compounds are made up of? Yes, these compounds are made up of carbon. Okay, so you can see here almost all the objects in our surrounding consist carbon. Okay, now can you think of a method to test this? Okay, so what would be the product if a compound containing carbon is burnt? So what happens when we burnt things which consist carbon? Okay, so when a carbon compound is burnt in presence of sufficient amount of oxygen, obviously the oxygen should be present, right, when we burn things. So the end product would be carbon dioxide and water. Okay, so these are the products formed when we burn a carbon compound. Yes, dear students, in this lesson we are going to learn about the carbon compounds, okay, and its properties. A food clothes, medicines, books, or many of the things that you listed are all based on this versatile element carbon. In addition, all living structures are carbon based. Okay, now let us see the occurrence of carbon. Okay, as I told you, carbon is present everywhere, but in which form it is present? Okay, what are its forms? So, carbon is found in the atmosphere, inside the earth crust, and in all living organisms. Carbon is present in fuels like wood, coal, charcoal, coke, petroleum, natural gas, biogas, marsh gas, etc. Marsh gas is nothing but methane. And carbon is present in compounds like carbonates, hydrogen carbonates, etc. And the last point is carbon is found in the free state as diamond, graphite, fullerene. So all these are what allotropes of carbon, right? So we can say that carbon is present everywhere in the earth. Okay, if you see periodic table, you will find carbon in 14th group. Okay, here you can see that the carbon element over here, it is present in 14th group element. Okay, 14th group we can see the carbon. So mainly it is non-metal. Okay, it is a non-metal. And do you know its atomic number? Yes, its atomic number is a 6. Okay, now you must able to write its dot structure. Okay, all of you try to write the dot structure of carbon. Pause the video and draw the structure. So what would be the outermost shell? So its outermost shell consists how many electrons? Can you say now? Because this topic we have already discussed in the last chapter, that is metals and non-metals. We have discussed the electron dot structure and the structure of atoms, right? So that its structure, that is like arranging the electrons in different shells. So since the atomic number is 6, its outermost shell consists of 4 valence electron, right? We got 4 valence electron, means outermost shell consists of 4 electrons. So its electronic configuration would be 2 and 4. Here you can see the structure of carbon. K shell consists of 2 electrons, that is filled, but L shell consists of 4 electrons, right? So its valency is a 4. So to attain octet structure, how many electrons it need? Can you tell me how many electrons it need to become a octet structure? Yes, exactly. It is a 4. Okay. See, students, you have studied about ionic compound, right? In metals and non-metals lesson, we discussed about ionic compounds. But how the carbon will form a bond? Now let's discuss about the bonding in carbon. Okay, it is carbon forms a covalent bond. Okay, so what is this covalent bond? Yes, let's discuss now. The atomic number of carbon is 6 and its electronic configuration is 2 and 4. It has 4 valence electrons. So it can attain stability by gaining 4 electrons, losing 4 electrons, or sharing 4 electrons with other atoms. Okay, its outermost shell consists of 4 electrons. So it need 4 electrons. Either it gains 4 electrons from other atoms, or it loses those 4 electrons and it becomes stable, or it shares 4 electrons and to become a octet structure. See, it does not gain 4 electrons. Why it can't gain 4 electrons? Because it is difficult for the 6 protons to hold 10 electrons. Suppose if it gain 4 electron, then what happens? Its proton became 6, electron became 10, right? So it is not possible. It can't hold the 10 electrons. 6 protons do not have that force to hold 10 electrons. Similarly, it does not lose these 4 electrons also, because to lose electrons, it need a large amount of energy to lose 4 electrons. Neither it gain 4 electron nor it lose 4 electrons. Then how it become octet? Yes, it shares these 4 electrons with other atoms to attain a stability, resulting in the formation of covalent bond. Now, can you define what is covalent bond? The bond is formed by sharing of electrons. In ionic compound, we studied that the bond formed by the either transfer of electrons, either gaining electron or by losing the electron. That is complete transfer of electron. Here what happens? Complete sharing of electrons takes place. Covalent bond formed by the sharing of electrons. Remember that. That is the main difference. Since carbon atom needs 4 electrons to attain stability, its valency is 4, so it is called tetravalent. Why it is called tetravalent? Tetra means 4, because it has 4 valence electron in its outermost shell. So this element is called tetravalent. So I hope this is cleared. Let's proceed further. Okay. Now let us study how the formation, that is covalent bond, forms in a carbon element. Covalent bond is chemical bond formed by sharing of electrons between atoms. The sharing of one pair of electrons result in the formation of single covalent bond. See, single covalent bond means sharing of one pair of electron, means 2 electrons. Pair means 2, right? That is called single covalent bond. Similarly, sharing of 2 pair of electrons results in the formation of double covalent bond. 2 pairs means 4 electrons. Okay, that is called double covalent bond. And sharing of 3 pairs of electrons results in the formation of triple covalent bond. Okay? Yes. For example, if you consider hydrogen atom, hydrogen. So how do we denote hydrogen usually? It is H2, right? Why it is H2? Why not H? Yes, there is a reason. Okay, let us see that. Atomic number of hydrogen is 1. It is present at the topmost element in the periodic table. If you observe the periodic table, so the first element is what? It is hydrogen. So its atomic number is 1 and its electronic arrangement is also 1. Now what is its valence electron? Yes, tell me its valence electron. It is also 1. So it need one electron more to attain stability. That is to become a duplet. Okay, not octet. Octet means 8 electrons. Duplet means 2 electrons. Okay. It need 1 electron more to attain stability. So, 2 hydrogen atoms shares one pair of electrons, resulting in the formation of single covalent bond in hydrogen molecule. Okay, see here, hydrogen consists one electron. It shares this electron with another hydrogen atom. Both the atoms shares these two electrons. This shares this electron with this electron. Similarly, this hydrogen atom shares its electron with this electron from the other hydrogen. So, they form a single covalent bond. Okay, that's what it is represented as H2. Similarly, chlorine, how it is represented? Cl2. Oxygen, O2. It is not existed as O. Chlorine is not existed as Cl. Always we write O2, H2, Cl2. This is the reason. Okay, now let's see the formation of double covalent bond. Okay, that is oxygen. And one more thing, how do we represent this single covalent bond? See, this is the notation. Okay, that is between two atoms, one line. This line indicates single covalent bond. Remember that. Okay, if it is double bond, then we put two lines. This is for double covalent bond. If it is triple covalent bond, then we put 3 lines. Remember that. Okay, oxygen molecule. The atomic number of oxygen is 8. Okay, it is 8. And its electronic configuration is 2 and 6. Okay, so outermost shell consists how many electrons? 6 electrons. So to become octet, it need how many electrons? 2 electrons. So it need 2 electrons more to attain stability. So 2 oxygen atoms share 2 pairs of electrons, resulting in the formation of double covalent bond. See this oxygen. This wrong sign indicates the number of electrons. Okay, so it has 6 electrons. To become octet, it need 2 electrons and one more oxygen. It combines with one more oxygen and shares these 2 electrons and becomes stable. See, this oxygen shares these 2 electrons and this oxygen shares these 2 electrons. So here the bond formation takes place. Okay, so this is the bond between these 2 oxygen atom. Okay, and this is the notation O double line O. Understood? Yes. The next one, that is nitrogen molecule. It is also represented by N2. That means 2 nitrogen molecule shares the 3 electrons. Okay, 3 electrons. So here 2 oxygen molecules shares 2 electrons. That is one pair of electron. Okay, here 2 electrons means 3 pair. 3 plus 3. Okay, one nitrogen molecule need 3 electrons. Then the other nitrogen also need 3 electrons. They mutually shares these 3 electrons. Then they become stable. Yes. The atomic number of nitrogen is 7. So its electronic configuration would be 2 and 5. So outer shell consists of 5 electrons. It need 3 electrons more to attain stability. So 2 nitrogen atoms share 3 pairs of electrons, means total 6 electrons, resulting in the formation of triple covalent bond in nitrogen molecule. So how do we represent it? Yes, N, then 3 lines. Okay, 3 lines. This shows that the triple covalent bond. I'll explain once again. So, hydrogen atom has 1 electron. So this electron combines with, shares another hydrogen atom. These 2 hydrogen atom combines, means they shares both the electrons and they become duplet structure. So this is the notation. Okay. Cleared. And we write H2 molecule. Then if you consider oxygen, it is 6, right? Its valency, total electrons are 6 valence electron. Okay, if I write like this, so these electron, it is shared by another oxygen atom. Okay, so this shares these 2 electrons and this oxygen shares these 2 electron. Okay, and we write like this, O2. I hope this is cleared. Now let's see the new compound, that is methane, Ch4. Okay, this is carbon compound, methane. It is called, this compound is called methane. Now can you draw electron dot structure for this compound? How can, so far now we discussed only the same atom, right? Like oxygen and oxygen, hydrogen and hydrogen, nitrogen and nitrogen. But here the elements are different. One is carbon, the other one is hydrogen. See why it is CH4. See, carbon has 4 valence electron. Those 4 electrons are combined with the 4 hydrogen atom to become a stable. Okay, if you draw carbon atom, it has 4 valence electron and these 4 electrons are shared by 4 hydrogen atom. Okay, so this is the dot structure of methane. Okay, so here bond formation takes place. Dot represents the number of electron in a hydrogen. The cross mark indicates the number of electrons in a carbon. So this is the dot structure for methane. Now I'll give you a homework. Draw electron dot structure of carbon dioxide, chlorine, ammonia, that is NH3, and sulfur. That sulfur consists 8 atoms. Okay, try to draw electron dot structure and upload it in your Seesaw app. Okay, this is the homework. Thank you. And we discuss the answers of these questions in the next class. Thank you.